Negative exponents. They're actually most easily understood by looking at first example before we even get started. So just look at an example with me. If we had, let's see, 4x squared over 3x to the third. Now you know that you could subtract the exponents, so you'd end up with x to the negative 1 in the numerator, but how do we deal with that negative exponent? What's actually going on? So I'm going to multiply out my 2x's in my numerator, multiply out my 3x's in my denominator, and you're going to notice that I'd have a pair of x's and another pair of x's that get crossed out. So you have 4/3 x. So basic idea, 4/3 and x's in your denominator, is when you have a negative exponent, you want to change its position. If it was in your numerator, you're going to move it down to the denominator, and that makes it a positive exponent. Okay, the converse is also true. If it was in your denominator, you want to make it negative, then you would just move it up to your numerator. So I'm going to say the same. Okay. So what I recommend doing whenever you work through these problems, so for example number 1, is always change it into a fraction. Now number 1 is actually kind of nice. You might be able to use another rule as you work through it. You're going to notice negative 2 plus 2 would be 0, and x raised to the 0 power is just 1, so 3 times 1 would just give you 3. For number 2, I would go ahead and change, well, it depends on how you want to go about it. Guess I would probably go ahead and change it so everything that's in the numerator that's positive, keep there. So 3 times 3 is going to be 9. P to the first stays in the numerator, but then p to the negative 3 you're going to move down to the denominator. Now notice 1 minus 3 is going to be p to the negative 2. Okay, you have a negative exponent, so 9 stays in the numerator, and p squared moves down to the denominator. Okay, number 3, for this problem here, you can leave 1 as a coefficient, or 1 as the placeholder in the numerator. Move both of the k's down to the denominator, so now they're both k to the positive 4. You can add them up, so it'll be 1 over k to the 8th. It keeps going like that. When you get down to number 7, this might be kind of an interesting problem to look at for a moment. Actually, I think number 8 would be even better. So number 8, you have 3b to the negative 1 over 3b to the negative 2. So what you could do, 3 stay in the same spot, but move b now to the positive 2 in the numerator and b to the first in the denominator. See here the 3's will cross out. B squared over b is just going to be b. Alright, let me know if you have questions. That is a little bit trickier of a concept. Next one, I'm going to do several together here, so maybe pause the video if you need to go back and practice. Number 5 is power of a power. So if you look at number 1, you have x to the third all raised to the third power. Now what that means is x to the third can be written out 3 times. If you remember your rules, 3 plus 3 plus 3 would be x to the 9th. Okay, number 2. 3n to the 4th all squared can be written out 2 times. 3n to the 4th times 3n to the 4th, so 3 times 3 is 9. N to the 4th times n to the 4th would be n to the 8th. Should be okay with these ones. If you wanted to, I could do maybe 9 and 10. It's just kind of the same idea, except you have 2 variables. So you're going to write it out 3 times. X to the 4th y squared, x to the 4th y squared, x to the 4th y squared. Which will end up giving you have x to the 12th and then y to the 6th, and then just adding up the exponents. Number 10. Here you have 3x squared y squared twice. Okay, so 3 times 3 is 9. You get x to the 4th and y to the 4th. If you flip over the page, it's going to be the same thing, but you're just going to have different things involved now with it. So if you look at product of a power, or power of a product, excuse me, what I'd recommend doing is simplify what you have in your parentheses before you write it out several times. So like here you can see 2 times 2 is 4, and it's p to the 8th all raised to the 4th power, so you could say 4p to the 8th times 4p to the 8th times 4p to the 8th times 4p to the 8th. So 4 times 4 is 16, times 4 is 64, times 4 is 256, and then 8 plus 8 is 16, plus 8 is 24, plus 8 is 32. For number 2, same idea. So before you write it out 3 times, I would actually simplify everything. So it'd be n to the third all raised to the third power, n to the third, times n to the third, times n to the third, which is n to the ninth. Now you'll notice with power of powers, you could actually just multiply it. So 3 times 3 would also give you 9. 3 times 3 would also give you 9. Okay, so simplify what you have in parentheses first, and then go from there. Number 7 is kind of challenging. 8, so we put those together. 7. So you have u to the 4th, b to the 3rd, times u to the 4th, all raised to the 4th power, raised to the 3rd power. Okay, so we got a lot going on. So let's simplify what's in my parentheses. So u to the 4th, b to the 3rd. Now u to the 4th to the 4th power. This 4 and 4, you can multiply them, so it's u to the 16th. Simplify things a little bit more. So you'd have u to the 20th, b to the 3rd, and you want to multiply this out 3 times. So you're going to have u to the 20th, b to the 3rd, u to the 20th, b to the 3rd, b to the 20th, b to the 3rd, so you're going to end up with u to the 60th, b to the 9th. Alright, number 8. 2a squared b to the 4th all raised to the 3rd power times ba to the 4th. As we multiply out this 3 times. And so multiply your coefficients. 2 times 2 is 4, times 2 is 8. And then ba to the, let's see, 2 plus 2 is 2. 4 is 10, and then b4 plus 4 plus 4 is 12 plus 1 is 13. So that should hopefully help you a little bit. Alright, one last thing, power of a quotient. Put everything together here. Alright, so same kind of strategy that I gave you before. I'd simplify what you have in your parentheses first. So this first one, 2m to the 3rd, so 4th power. Now 2m to the 3rd, you know 2 to the 3rd power, so 2 to the 3rd power would be 2 times 2 times 2, which is 8m to the 3rd, all raised to the 4th power. And you're going to see you have 1m on the top and you have 3 on the bottom, so really you could just simplify it to be 1 over m, 8m squared to the 4th power. You can write this out 4 times. So let's see, 8 times 8 is 64, times 8 is 512, times 8 is 496, m to the 8 power. Okay, you may get some larger numbers when you work through these problems. Number 2. M to the 3rd all over m to the 4th all squared. Simplify that, that becomes 1 over m squared. So 1 over m times 1 over m will give you 1 over m squared. Okay, so try your best with these ones. Again, simplify what you have in parentheses, and then work from there.